Hello, welcome back. We're going to talk about linear velocity now and how it relates to angular velocity and angular displacement. The formula for linear velocity is velocity equals the radius of the circle times this whole quantity here, which is angular velocity. We remember that this theta here is going to be the angular displacement and t is going to be time. And we remember from the previous video, omega equals theta over t. So we can basically substitute the omega, which is angular velocity, in here, giving us a new equation that is v equals r times omega. So this is the formula we want to use. And let me show you what it's all about. So I have a picture here of basically a roll of toilet paper, and imagine it being unrolled really fast. The speed in which the paper's coming down like this is its linear velocity as as it relates to how fast the circle is spinning here. So I want to give you a couple examples. First one is number 19, and it looks like this. It says one. Actually, no, it's not 19. I'm sorry. It's number 28. 28, and it says 16.6 radians per second with a radius, circular radius, equal to 8 centimeters. So, and you want to find its linear velocity. And of course, to do that, if we just use this equation right here, this is kind of all set up for us. We just say velocity equals the radius times the angular velocity, which this is omega right here. Okay, that's our angular velocity. So if we just multiply this, it'll give us our linear velocity. So it's 8 centimeters times 16.6 radians per second, and that's going to give us a linear velocity of 132.8. And that will, of course, be centimeters per second, and that's its linear speed. It's coming out at a rate of 132.8 centimeters per second. If we had a larger roll of tissue, toilet paper, whatever, and you're spinning it at that rate, this is going to increase. Of course, it's directly proportional to the radius. Next example is number 31, and it looks like this. It just gives you the angular velocity in a different format. It's 75.3 pi radians per second, and with a radius of 17 inches. It's huge there, whatever that is. When you do something like this, of course, it's going to be nothing more than radius times omega, which is the angular velocity. If you are confused about what all these new vocabulary words mean, go back and watch the other video, and it'll make more sense. You may have to go back and forth and rewind this a couple of times to make it make sense, but it will. So this is the angular velocity. This is the radius. If I multiply them together, I'm going to get the linear velocity. So v would equal 17 inches times 75.3 pi radians. So that's basically 75.3 times 3.14. I'm going to use the generic pi. And when we do all that, that's going to give us about 4,019.5 inches per second. Now, any of these you could easily convert into miles per hour if you wanted to know such a thing. And the applications to this are just huge in the realm of science. So I will talk to you later. Linear velocity.